For a sequence, an is equal to arctan n plus 2 minus arctan n, evaluate the series, starting with a0, then plus a1, plus a2, and so on all the way up to infinity. Okay, evaluate. How could we evaluate something like this? And we could start by playing around with some partial sums. So for example, if I were to compute S3, so that's A0 plus A1, just leaving myself as much space as possible, A2 plus A3. Okay. A0 is arctan 0 plus 2, which is 2, minus arctan at 0. Okay. A1 is arctan 1 plus 2, which is 3, minus arctan of the index 1. Okay, and then we get arctan 4 minus arctan 2. That's A2. We'll put A3 down here. Arctan 3 plus 2, which is arctan 5, minus arctan 3. You might notice, oh, there's a minus arctan 2 and an arctan 2, arctan 3 and a minus arctan 3 here. Things are canceling out, so we could naturally ask, is this sequence or is this series telescopic or telescoping? So if that were the case, that would present a great way to evaluate this series. Okay? But we'd have to ask, is there a sequence of bn's and some positive integer d so that the terms in our sequence can be written as bn minus bn plus d? Now we're kind of lucky here because the terms in our sequence are already expressed as a difference. And when you line up what you'd like for a telescoping sequence, you can kind of match, okay, arctan n and bn. Arctan n plus something, bn plus something. Really seems like d should be 2. And maybe we get something like bn is arctan n. Right, but if that were the case, an would be arctan n, okay, from the bn, minus arctan n plus 2. And that's not what we've got, so we're off. Bn should be minus arctan n. But if we do that, then yeah, this is telescoping. Okay. And how do we evaluate? Oh, it's starting with n equals 0, isn't it? How do we evaluate a telescopic or a telescoping series? Okay. It's the sum of the first d many b terms. So since we're starting with index 0, it should be b0 plus b1 rather than b1 plus b2. Minus the limit, as n tends to infinity, of 2 consecutive, 2 because of d, so d consecutive b terms being added together. Okay. If this limit exists, the series converges, and it converges to this value. Okay. So we'll need b naught and b1. And it's minus. Did I write minus? Yes, it is minus. Okay. Minus, and then this limit. Okay, so we need b naught. So that's going to be minus arctan 0. Plus b1 is minus arctan 1. And then minus the limit of minus arctan n plus 1. I could very easily see screwing up a sign if I were rushing this. Minus, well, plus minus arctan n plus 2. Now arctan at 0 is just 0. So we've got 0 minus arctan of 1. What do you have to put into tan to get out 1? Pi by 4. Okay, and then I'm going to switch this to a plus by bringing out these minus signs. Now, as n gets bigger, n plus 1 and n plus 2 will also get bigger. And as you put in bigger and bigger values into arctan, and what happens? Well, it tends to pi by 2. So the limits for both of these are just going to be pi by 2. So we have minus pi by 4 plus 2 pi by 2. So that's going to be pi minus pi by 4. And so the sum here is going to be 3 pi by 4.